Hello, this video is about parametric equations. So as you can see on your notes, the definition of a parametric equation is the graph of the ordered pairs x and y, where x is a function and y is a function, and they're defined on the interval I of t values. That's called a parametric curve. The equations are parametric equations for the curve, and the variable t is called a parameter, and I is called the parameter interval. So, long story short, think of it as just a graph, but the x and y coordinates are functions. So in this first example, it says for the given parameter interval, graph the parametric equations x equals t squared minus 2 and y equals 3t. So really another way you could write this if you're confused is x and y, but x is t squared minus 2 and y is 3t. So here are a, b, and c. Here are some examples we're going to do, and there's also an interval for us to work with. So luckily we have these tables. We're going to fill them out. So let's start with this first one over here. So for t equals negative 3, first I have to plug it into x. So I plug in negative 3, I get 9 minus 2, which is 7. I do the same thing for y, I get negative 9. For negative 2 squared is 4, 4 minus 2 is 2. If I plug in negative 2 into this one, I'm going to get 3 times negative 2, which is negative 6. If I plug in negative 1 into here, I'm going to get 1 minus 2, which is negative 1. If I plug in negative 1 into here, I get negative 3. If I plug in 0, this disappears. I get a minus 2 or a negative 2. If I plug in 0 into the y coordinate, I get 0. And the last one, if I plug in 1, I get 1 minus 2, which is negative 1. And if I plug in 1 here, I get 3. So what's left now is I use these coordinates to graph. So you may notice on the graph, there's no t variable. It's just x and y. So what I'm going to do is I'm just going to look at, here I have it in blue. I'm going to start plugging in those numbers. And with these numbers, you may notice that some of them are very large, and there's no dashes on this graph. So I'm just going to kind of guesstimate where these are going to be located. So first of all, I see 7, negative 9. So on my graph, I'll zoom out a little bit. I'll go 1, 2, 3, 4, 5, 6, 7, and I'll go down 9 spots. 1, 2, 3. So my first dot is going to be right there. The next one is 2, negative 6, so I'll go over 2, down 6. Again, these are estimates. It's not the most accurate of graphs. I'm going to get negative 1, negative 3, so I'll make one over here. And negative 2, 0. How about I put this in a different color? There you go. And then the last one is negative 1, 3. And here's my parametric equation. I'm going to put it in red. You're going to notice that it looks a little bit different. So these graphs, you may notice, they are, since each one is a function, they don't necessarily look like the ones that you've been working on in the past. So it doesn't look like a parabola or things like that. You can actually get some really unique shapes like a heart or a spiral because the x and y coordinates are, oh, sorry, I didn't know you can't see it, but there's my graph. You get some weird shapes because both of them are their own functions, and you'll get different shapes than what you're used to. Eventually, I'll also show in a graphing calculator how to graph a parametric equation. It's also very simple. Now, sometimes when a curve is parametrically defined, it is possible to quote-unquote eliminate a parameter and obtain a rectangular equation in x and y that represents the curve. So another thing that you can do is, that they'll ask of you, is to eliminate the parameter. So I know there's 2 other examples here for you. I think you obviously are in AP Calculus, so you didn't understand like how to do the rest of it. But what if I looked at these 2 equations that I worked on before, t squared minus 2 and y equals 3t, and let's try to eliminate the parameter. So first thing I'm going to do is I'm going to write out the equations. So I'm going to get, one of them is t equals, oh sorry, x equals t squared minus 2, and y equals 3t. So those are the equations that we were working with earlier. Now, eliminating the parameter means you're going to solve for t, and you're going to plug it into the other equation. So you've done a lot before in math, substituting an equation inside another equation. So since I'm solving for t, this one down here looks much easier to solve for t than this one. You could use either equation, but this one, since there's not to the second power, it's just this will be much easier to solve for t. If I do so, I'll divide both sides by 3, and I get y over 3 equals t. Okay. Now I will take this y over 3, and everywhere I see t in the other equation, I will plug it in. So this new equation that I'm creating is going to look like x equals y over 3 squared minus 2. And again, all I did was solve for t and plug in what I found into the other equation everywhere I saw t. Now all I do is simplify. This one's going to be, again, we did exponent rules at the last video, so y squared over 9. I'm squaring both top and bottom, minus 2. And that's how you solve by eliminating the parameter. So basically, it's a way for you to take a parametric equation and make it a normal equation that you're used to, just x and y without the t. Now, let's do the same thing on one more example where we graph and eliminate the parameters. So in this one, they give us x equals 1 minus 2t, they get y equals 2 minus t, and they give me an interval, a parameter interval of everything, negative infinity to infinity. And it says create an x and y chart allowing t to be anything. So really you could just choose whatever you want. To make it simple, or even just for this video, I'm going to do -1, 0, and 1. And then just because we just want to get through the example and you'll understand what we're trying to do. So first one, t equals -1. Again, so I'm going to plug in -1 here and -1 here. If I plug -1 here, this becomes plus 2. 1 plus 2 is 3. If I plug in a -1 here, I get 2 minus a minus 1, which becomes 2 plus 1, which becomes 3. If I plug in 0, this disappears, I get 1. If I plug in 0 here, this disappears, I get 2. And the last one, if I plug in 1 here, I get 1 minus 2, which is -1. And if I plug in 1 here, I get 2 minus 1, which is 1. Again, there's 3 more spots. You should graph more, but for the sake of this video, we're just going to stop there. Now I'm going to graph it onto my axes on the right. So I have -1, 0, and 1. Oops. I'm going to label this axis x and this one y. Again, I made the mistake. I just put -1, 0, and 1, but in this case, remember, we're just graphing x and y. So first one is 3, 3. So there's 3, 3. The next one is 1, 2. So 1 and 2. And the last one is -1, 1. So it looks like this. I don't know if it'll curve or look any different. Oh, wait. Sorry about that. 1, 2, -1, 1. Oh, I did it right. So it looks like, so far, and I don't know how the rest of the curve looks like, but so far it looks like that. There's my parametric equation. Now, the second step is eliminate the parameter of the equations and give the resulting rectangular equation. So I'll take my two equations, x equals 1 minus 2t, and y equals 2 minus t. There it is. I need to solve for one. Remember, I'm solving for t and finding the other one. To me, this looks like, because t is by itself, this looks like the easier one to solve for. Okay, so what I'll do is I'm going to subtract 2 from both sides. And I almost have t by itself, but I have this negative, so what I'm going to do is I'm going to multiply everything by -1 to give me t by itself. There you go. I've solved for t. Now that I've done that, I'm going to take whatever I found for t and place it in the other equation everywhere I see t. So I think you have a lot of space on your paper, but I'm gonna bleed into the other question here. So what happens is I get x equals 1 minus 2 negative y plus 2. So all I'm going to do left is just simplify, multiply the rest of it. I'm going to simplify it. I'm going to get x equals 1 plus 2y minus 4. I'm going to get x equals 2y minus 3. So those are the only two skills you really need to know about parametric equations. You need to identify what one looks like. I think you guys will, or I think you all understand how that looks like. Once you know what a parametric equation looks like, you should know how to graph it and eliminate the parameter to get just a rectangular equation. When they mean by rectangular equation, they mean they really just mean the equations that you're used to, like y equals or x equals, without a t variable. So that is parametric equations. If you have any questions, please feel free to ask me in class, and I will see you later.